Let us look at the first of the three areas, the area of BIM, where it is the backbone of the VDC, or it is in a sense of the software that is used to manage all the different types of information that will be created, okay, has been created, is in the process of being created. All right. So under the area of this BIM, okay, there are actually three subfamilies that we'll be discussing in quite a lot of details, which is the products, okay, the content, and the quality. So you will appreciate that in the process of coming out or constructing a facility, there will be many different types of information that is going to be generated. Some types of information are what we call geometric information. Geometric information can be an example, say a beam, where you know, okay, or what has been modeled, okay, is the dimension of the beam. Okay, so that is a geometric information. Okay, example of information that is a non-geometric. Okay, non-geometric. It will be, for example, the beam actually is a reinforced concrete. This beam, and the reinforced concrete grade is 40. That's an example of a non-geometric information. Another example of a non-geometric information could be this fire rated door. Okay, or the fire rated door, non-geometric information. It basically tells you that the fire rating is 2 hours, for example. Or it tells you that this particular door is acoustic rated. Yeah, the geometric information will be the dimensions, for example, 1500 by 2100. Okay, so there will be a lot of information that is going to be created in the process of coming up with this physical construction of the facility. Okay, so that's why you need to look into the product, the content, and the quality, which we will be going to go through in the next few slides. So when we talk about the BIM products, okay, sometimes we also refer to it as the different type of BIM models. Okay, the different type of BIM models. In a sense, from the initial conceptualization stage of this project, the BIM model may not be very sophisticated and may not carry a lot of information because it is still in the feasibility or conceptualization stage. And as the project then goes on to the next phase, to the next phase, to the next phase, along the various phases, because of the needs of that particular phase, more and more information is created, and you can have other what we call BIM users lah, okay, or BIM models. So it can be then a more a concrete 3D model, and then after that it can progress to, for example, a discipline model, say structural, or a discipline model architectural. Or when it goes on to the construction stage, maybe there is some kind of a coordination model. So along the different phases of the project delivery life cycle, there are different models or different types of products. Okay, in terms of BIM, okay, models. Okay, so the BIM product pertain to specific BIM models, okay, to be produced in alignment with the project objectives and activities. So everything is very focused. Okay, this BIM product is basically created in order for you to achieve the required project objectives. Okay, in the activity, so that you can achieve the goals. Okay, so the key principle is that know what your objectives and activities are first before determining the specific models that you want to produce. Okay, determine who is the most appropriate author for each model that is going to be developed at the different phases of your project. The models may have multiple model use. Yeah, and it is ideal that content, okay, which must be able to satisfy all the different model users. Okay, yeah, and you ensure that you have interoperability, okay, across all models to be shared. Okay, because again, the different groups of people that is using the model may actually export or import it into a different design platform. Okay, so remember we talked about the .ifc format. Okay, so that's one way to ensure that the output and the input, they are consistent, so that whichever design platform you are using, okay, the design platform can talk to each other in terms of accessing the information from the model. Okay, so ensure the ease of a model update throughout, through proper model setup and management. Okay, so by product components, okay, we are saying that the BIM product consists of information models and also the model users. So information models, okay, form the cornerstone of all the VDC efforts, as they are the repository. Okay, that means it's a location where the data are resided. Okay, so as such, the validity of the data inside the information model should be dictated by the suitability for use. And then you also have the model users. Model users can drive the data inside the information model, and they in turn are driven by the specific targets and the activities as predetermined by the project teams. So to fully maximize the benefit of BIM and VDC in the integration of the entire project lifecycle, the model must progress seamlessly from different phases from the design to the construction to the operation, through timely incorporation of the required information, okay, and geometric detail as dictated by the specific activities and deliverables at every stage. So this entails process transformation at certain key junctions, wherein regulatory submissions model must transit, okay, for use in tender preparation. The design intent model must be handed over downstream to be further developed to be fit for construction. Model progression and timeliness of the activities must align with the master schedule and targeted milestone. What it means is that as your BIM model, okay, or BIM models change and evolve and develop from the different stages or different phases of your construction, okay, more and more information will need to be added or need to be required from the model. So that's why you need to make sure that at different milestone, okay, locations, okay, of your project delivery life cycle, okay, the model is ready, okay, to be able to allow the different stakeholders to do their work. Okay, for example, okay, by the time you reaches the submission stage, okay, the model must be sufficiently built up to allow the regulatory officers to be able to do their checking, okay, code checking and all that. Right. By the time you come to the tender preparation, okay, the end of the this tender preparation stage, the model must be sufficiently built up to allow the costing, okay, or quantity taking off, okay, allow visualization, allow planning, okay, or so and so forth. In terms of the model information types, you can have generally the design models, okay, versus the construction models. Yeah. So the design intent model will progress, okay, from schematic design all the way to the construction as built. So design models capture and convey the project design requirements for the purpose of visualization, analysis, integration of the different disciplines, for example, architecture, civil, structural, mechanical, electrical, so on and so forth, communication and record. Yeah, and you can have what we call an e-submission model, or it is a model that complies with all the requirements for e-submission and is submitted to the respective regulatory agencies. Yeah, so you can actually refer to this code of practice for BIM e-submission when you want to know more about the requirements of this e-submission model. Then you can have a tender model, which is a design intent model that is fit for use for the bidders, okay, during the tender period. And you can also have what we call a handover model, okay, which is a design intent model that is handed over to the contractor, not to the end user yet, okay, but is to the contractor. Typically, it's because the project delivery is in a form of design, then after that bid, and then after that build. Okay. So if it's a design and build, okay, typically there's no handover because both the designer and the contractor, they are in the same organization. All right. Okay. But because in this case, if it's a design, bid and build, okay, the designer, okay, and the contractor that come on board at a later stage, they are not from the same organization. So that's why you need to have an official handover model. All right. Now then, for construction model, depending on the availability of the handover model, construction model are either developed from scratch, which is typically a waste of effort, if you ask me. Okay, or it's better to use, okay, whatever information that already been put in, okay, in the handover model to then continue lah. Okay, or expanded from a design intent model. Okay, so construction model must be fit for specific activities, analysis, service to be fully exploited, okay, the benefits of BIM and VDC during the construction stage. And you can have a construction-based model, for example. Or they are the contractors, they are the main, this architectural and CS model, they are handed over, okay, by the main contractor and used as a base or reference for the different subcontractors. Okay, yeah, then you have the individual trade models. Okay, trade models are usually developed by the subcontractor or the specialist contractor for that particular specialist trade. Okay, and integrates the fabrication details and the domain knowledge into the model. So you can also have a virtual mock-up or digital prototype. Or these are models of isolated areas in the project that have been developed to a very high level of detail and accuracy for the purpose of constructability and sequencing analysis, for visualization, for virtual review, or for fabrication. The model or models must be set up in a way that facilitate ease in the model update and ease in downstream use. And typically, these are some of the considerations when we are setting up the model. We need to look into the project complexity. We need to look into the design intent, typicality, the location-based planning, and the scope of work. All right. Interoperability is very important, because we are doing a lot of collaboration between the different parties that could be using different platforms when they are handling the data from the model. Okay. So collaboration in a BIM environment requires model and software interoperability for seamless exchange of data between the participants of the project. So interoperability should be ensured, okay, that the data created by each party translate correctly in terms of both geometric and non-geometric attribute for accurate reference by all users for each model. Also, I've gone through examples of geometric data and non-geometric data. Yeah. Under the model uses, the information model may be fully exploited to perform a number of value-added VDC services, but only if it contains the appropriate information to fulfill each type of services. Meaning that, for example, if you are going to use the model for this visualization of the scheduling, then it should be what we call a 4D model. But if your 4D model does not have enough information in relation to the scheduled activities, then the model cannot run properly. Okay. So all these model users and digital analysis may be classified according to various dimensions of BIM. You can have a very basic 3D BIM model, which includes the geometric information. Okay. All right. Then you can include the schedule. It becomes a 4D model. Yeah. And you can include the costing. Becomes 5D. Okay. Include the this operation and maintenance data, then it becomes 6D. Okay. So this diagram here shows you the basic attribute of the different versions of the model from 3D, okay, 4D to 5D to 6D, and the different users, okay, of the 3D model, 4D model, 5D model, and even 6D model. All right. So in a way, you can see that the model is very versatile and it can serve a wide variety of stakeholders at different phases of the project.